So for case one, we're going to log in with our UPIC user. And we're going to add a crime to the system. We're going to give the crime a case ID number. It was on March 3rd, 2021. The description of it, we're going to copy the description that we were given of the robbery at the GameStop. And then the suspect's description, we're also going to put in the crime description. The case has not been solved yet. There's one witness who is also the victim. So I'll enter his information now. Male, his address, we're going to copy from the given information. Same with his phone number. The witness is still living, and he was a victim because he was the one held at gunpoint. His statement, we're going to include that, the one that was given to us. We have no items of evidence. We do have one suspect, though. Name is unknown. He is living. He's male. No known aliases. No known address. No known phone number. No known accomplices. No known acquaintances. We know he has brown hair, blue eyes, no tattoos, white skin color, American nationality. We'll put in an estimated weight. He was around 5'9", so 69 inches, around the age of 18, does not wear glasses, no known disabilities, no known handness. He has not been arrested or charged, not in jail. And there we go, we have that added. So now we're going to use the system to search information.
All right, if we're searching now, we're on a case, we're searching for a criminal murder suspect, and we know he's 30-year-old male with thick black hair, and he's 6'2", and we also know he has a dove tattoo. So we are going to search for the dove tattoo. So we're entering the number for that, and specifically for a dove, and there's 2 results. So we're going to print them to the terminal so we can see them. And we see there is a woman that's 44 and another man that's 21. So none of these fit our description. So we're going to search again using 3 different criteria. The first using age, which is number 17. And we are looking for a 30-year-old. With 3 results, but we're going to keep on narrowing it down, see what we've got. So we are going to search for hair color, and the hair color is number 9, and we're looking for black. That's our value. We're not going to print yet. We can print at the terminal if we want, but we are going to search one more time using height, which is number 15. And 6'2" is 74 inches, so we'll look for 74. All right, we've got 3 results, so we're going to print them out and look at them real quick. And we see we've got 3 different men who all kind of fit the description, but none of them fit exactly. JJ, Alston, and Bradley, they all have black hair, 30 years old, and 6'2". So they could be any of those guys. So we're going to save this information and print it in the text file.
And then, so for the third scenario, we're assigned to a case. So we're going to exit out to the main menu. We are going to search for a crime that has the case ID XXX. And they found the crime in the database. We do want to print it to a file, and we do want to print it to the terminal. So you can see here in the terminal that it prints out with the case information, the suspect, and all the unknown information about them, the 3 pieces of evidence, and then the 2 witnesses, which one of them is a victim. And that same exact information is printed out to this text file here in that same exact format.
I'd like to talk about the crime UMI. For that one, that interacts with the crime vacate. Now, what the class have in common is you're going to see user database, person database, and crime database. They have all react with crime vacate class. As you can tell, for the user class, it only reacts with the user database. We're just going back and forth, back and forth. And for the data loader, I'm sure that's involved with the user database, person database, and crime database also. Now, as much as the data writer, they're the same thing. Like I mentioned before, just the user database, person database, and crime database. Now, for both data loader and data writer, it goes to the data context. So you're gonna see where it says the crime, witness, criminal, evidence, and a user for its contents. Next, I'd like to go over for the crime classes. Now, for the crime classes, it involves with the evidence, the crime database, witness, and the suspects. But the evidence is the only thing that involved with the crime, along with the witness as well, and of course the suspect. Now, as long as with the person is coming from the witness and the suspects.
Additionally, in the UML, the data constants extend the data loader and data writer, and the person class is inherited from witness, suspect, and suspects.
So our data writer class follows the observer type structure, where it's called to update the data structures every single time a change is made or an update is made into our code. So when it calls the data updater, it uses both JSON and GSON to write to the files and create these objects that are used to store data between the closing and the opening of new applications. Using the data constants, it's able to keep track of the set spot for each of the different variables, and using UUID as seen in this JSON file, it's able to connect things such as evidence that are stored in a different JSON file to the objects that are used in things such as crime. In addition, we have file writing as seen in this crime class here, which will pull in the FIDA from these array lists and be able to utilize that.
We mainly use two different types of design patterns. The first pattern is the singleton design pattern, which is used in our 3 database classes. We use the singleton design pattern because we wanted the database classes to have only one instance and provide a global point of access to this instance. One example of this is if you look at the crime database. The crime database sets up an instance of the crime database as static and has a global point of access to it with the method getInstance, which is shown on the screen. The second design pattern is the facade design pattern. The facade design pattern defines a higher level interface that makes the subsystem easier to use. We use the facade design pattern because we wanted to make the crime UI less complex and to make our code easier to use. The methods in this class interact with the other classes so that the methods in the crime UI can call these methods to simplify the usability. So if you look at any of the methods, they all interact with the other classes, and then the crime UI interacts with the facade.
Ali just talked about the facade and the singleton design patterns, and this is our example of that in the crime UI. So the crime UI is what runs the methods, it is the main interface that has the main method in it. And it's got a main run method that basically calls on the facade to run everything. So you have the person logs in, then it checks if they're an administrator or a normal user. Then you get all these different case statements asking which one you want to do. It's our user interface as to what the person sees. And then from there, it has methods. All the methods it has basically just gives the user the interface that prints the console and has a scanner where it can collect data from that by keystroke, and then it calls all the stuff in the facade. You can see it calls different methods. All the same facade has the same methods that it calls. So everything runs from the facade, while the UI simply has all the user interface stuff, which gives low coupling.
All right.